right, today we're going to look at lesson 5.2, and we've already looked at transforming or transformations of functions, and now we're going to look at transforming linear functions. So remember, a linear function is an equation of a line, and function just means it passes the vertical line test. So let's start with task 1. Transform the graph of a parent function. A family of functions is a group of functions that have basic characteristics in common. Graphs of functions in the same family are transformations of the graph of the parent function. The parent function is the most basic function with the defining characteristics of the family of functions. The parent function for all linear functions is y equals x, and f of x is just function notation for y equals x. So f of x equals x. Notice that f of x equals x has the form y equals mx plus b when your slope is 1 and your y-intercept is 0. So the graph of the parent function has a slope of 1 and a y-intercept of 0. Consider families of linear functions whose graphs are transformations of the graph of the parent linear function. When comparing transformed graphs of the graph of f of x equals x, observe the following 3 characteristics: your direction, your steepness, and your y-intercept. All right, so you're going to decide if your direction of the graph is still rising, falling, or neither. And you always look at the graph from left to right. You're going to determine whether graph is more vertical, less vertical, or horizontal compared to the graph of the parent function. And you're going to determine whether the y-intercept has changed. All right, so you can translate the graph of the parent linear function by adding or subtracting from the range. The graphs of G1 and G2 are translations of the graph of f of x equals x. Okay, so remember, this is your parent function, and these are in your family of functions because they have the same characteristics, okay? All right, so blue is your parent function. That's y equals mx plus b, where your slope is 1 and your y-intercept is 0. Okay, that's f of x equals x. All right, so what they're going to do is take the parent function, and for g, they are going to add 2. And you can see how that plus 2, just like in the last section, it just shifts the graph up 2. And then when you subtract 2, the green one, it shifts it down 2. So these are called a family of functions because they have similar characteristics. All right, choose the words that best complete the statements comparing the graph of g of x equals f of x plus k to the graph of f of x equals x. All right, so in each of these, we can look at and we can see that the y-intercepts are different. The directions, they all go up from left to right, so the directions are the same. And the steepness of the line, the slope of each one is the same. All right, you can reflect the graph of the parent linear function across the x-axis by multiplying the range of values by -1. So g of x equals negative f of x. So you can see the original parent function, f of x equals x is here. We multiply it by negative. It changes, it's a reflection across the x-axis, and it is now going down from left to right instead of up. All right, so let's see what this says. The y-intercepts, they both cross at 0, so the y-intercepts are the same. The directions, one's going up and one's going down, so the directions are different. And the steepness of the line, they still both have a slope that is the same. Just different direction. All right, it says you can stretch and compress the graph of a parent linear function by multiplying the range of values by a number. All right, so we've got g of x equals 2 times f of x. All right, so you can see g of x got steeper when we multiplied it by 2. That changes your slope. And this g of 2 equals 1/2 f of x. that shows you how it's going down. So your slope became 1/2, 1/2. So it's not as steep here. All right, so it says choose the words that best compare the statements comparing the graphs of g of x equals k times f of x to the graph of f of x equals x, your parent function, when k is a positive number other than 1. So your y-intercepts are the same. You can see they all cross at 0. The directions, they're still all going the same direction. They're still all going up from left to right. And this time the steepness of the line is different. Okay? All right, combined transformations. You can combine a vertical stretch or compression, which may or may not include a reflection across the x, with a vertical translation. For instance, consider the graph of g shown. All right, so we still have f of x, our parent function here, and g is our transformation. So it says choose the words to best complete the statement showing how to transform the graph of f into the graph of g. All right, so you need to multiply f by a positive constant that is greater than 1 because it got steeper. And then you need to take the result and add a positive constant to obtain g. All right, add a positive constant because we are adding to move the y-intercept up. Okay? All right, now it says enter a number in each blank to create the rule for g of x in terms of f of x. All right, so f of x is, okay, so you know the rule here, we already said that the parent function has a slope of 1. So let's determine what is the slope of g of x. So if I go up 1, 2, 3 over 1, so I've got a point here and a point here, so my slope is now 3. So that means my steepness is going to be 3 times f of x, and then my y-intercept went from 0 up to positive 4. So my positive constant will be 4. All right, that's all for task 1. If you have any questions, let me know. All right, this is 5.2, task 2. Translate the graph of the parent linear function horizontally. All right, the graph shows translations of the graph of the parent linear function. All right, so you can see in this graph they are shifting this point horizontally. So you go left to go to the red and you go right to go to the green line. So this is G1 and G2. So this is shifting this horizontally. So it's a horizontal translation. And then this one is going to be a vertical translation. So if it moves up or down, it's going to be vertical. So if you shift it up, that's G of 3. If you shift it down, that's G of 4. You can see that these are identical. So we're going to talk about that. Okay? All right, so it says choose the words that best complete the statement. Horizontal translations. Horizontal, remember, is on your x-axis. Horizontal of the graph of f of x equals x. So that's your parent function. So horizontal does, or they do affect the domain of the function. Vertical translations of the graph, vertical means up or down of your parent function, and they do affect the range of the function. Okay, so horizontal is going to affect the domain, vertical will affect the range. All right, the graph of g of x equals f times x plus k is a horizontal translation of k units of the graph of the parent function. If k is greater than 0, then the graph translates k units to the left. And if k is less than 0, then the graph translates k units to the right. Use the information to match the 4 functions to rules in terms of f of x. All right, so you can see g of 1, g2, g3, g4. All right, so let's go back up to our picture here. And so from f to g1, we went left 2 units. So if we go left 2, that's in the parentheses and it's opposite the sign. Okay, G2 goes the other way, so that's going to be our -2. So we can go up here and see that this moved to the other direction. So that's why it's -2. It's going to be a plus moves you left and a minus moves you to the right. All right, now vertical, up moves you +2, down moves you -2. So G of 3 will be +2 and G of 4 will be -2. All right, so it's just matching these to what the actual function would be. All right, it says given that f of x equals x completes the direct rule for the 4 functions in terms of x instead of f of x. All right, G of 1, so we added 2, and then we subtracted 2, and we added 2, and we subtracted 2. So this is just based on these up here. G of 1, we did add 2, here we subtracted 2, then we added 2, and then we subtracted 2. So that's just based on what we looked at from the graphs. All right, so it says choose the words that best complete the statements. The graph of G1 and G3 are identical because f of x plus 2 equals f of x plus 2 for every linear function with a slope of 1. Okay, so if the slope changes, then the family of functions would change. But if it has a slope of 1, like ours does, then G of 1 and G of 3 were the same. Identical formulas yield identical graphs. The graphs of G of 2 and G of 4 are identical because x minus 2 equals f of x minus 2 for, again, all linear functions with the same slope. All right, so if you go up here again and look, you can tell in the very beginning, even though this one was looking at a horizontal translation and this one was looking at a vertical translation, if you look, this goes through -2 and 2, and this goes through -2 and 2, same line. We already know the parent function is the same in blue, but this one also goes through -1, -3, and -2, and this one goes through -1, -3, and -2. So those result in the same thing when it's a linear equation with the same slope. All right, that's all for task 2. If you have any questions, let me know.